Okay, so what about vector direction? Let's talk about vector direction, another property of vectors. We already talked about it a little bit, but that was just in the sense that vectors have magnitude and direction. Now let's just talk about the directions, how we denote directions. So let's say I have a vector and I just put it on, it's pointing at 6 miles in the direction given, which could be south of west if this was a compass rose. But let's put it on an xy axis and just talk about what it is relative to the xy axis, what direction it is, because that's the most common thing we're going to use is an xy axis. So d is equal to 6 miles, right? And what's its angle? Well, right now I've drawn it as 45 degrees from the minus y-axis, but in which direction from the minus y-axis, right? Because we can go left or right. Go left of the minus y-axis, or more likely, because it's really that we would go in a circle around the origin, it's going to be clockwise from the minus y-axis. That is actually the direction, right? It's 45 degrees clockwise from the minus axis. So CW means clockwise. That looks like dockwise. Actually, I'm not entirely sure what it looks like. It almost looks like dodwise, but that's clockwise. And CCW means counterclockwise, right? Here's a clock, and here's the big hand, and here's the little hand. And as time goes by, right, the clock hands go this way. That's clockwise. Ah, you knew that. I was kidding. Okay. So this is the correct way to denote the direction. Or you say, well, that seems a little awkward. 45 degrees clockwise from the minus y-axis. Well, that's, I'm not sure how else you want to do it. Now, you might have learned in some math class at some point that you should always measure your angles counterclockwise to the plus x-axis. So this would be d equals 6 miles long, and it is how many degrees from the plus x-axis? It's 180 plus 45 is 225. 225 degrees counterclockwise from the plus x-axis, right? That's no less awkward. You might say, well, I don't need to tell you it's counterclockwise from plus x-axis. Indeed you do. This is physics, not math. You have got to tell me relative to what axis you're measuring. You have got to tell me relative to what axis you're measuring, because if I gave you this problem, most of you would just, and I told you, and I didn't make you tell me what axis you're measuring relative to, most of you would just tell me it's 45 degrees. You wouldn't think to tell me it's 225. So you've got to tell me the axis you're measuring relative to. Okay, so is there any other way to denote this vector? As a matter of fact, there is. There's actually an infinite number of ways, right? Because I can just measure it relative to any axis, right? So it's 45 degrees counterclockwise from the minus x-axis. I can measure it relative to any axis I define. I can also say it's, 360 degrees plus 225. So it's also 585 degrees counterclockwise from the plus x-axis, right? I mean, I can go full circle, 360 degrees, plus 225 more. Or I can say I can go backwards from the plus x-axis, or clockwise from the plus x-axis, which is 90 plus 45, 135 degrees. 135 degrees. What was that? From in this direction. Clockwise. CW from the plus x-axis. All right, so on and so forth. All right. So there's so many ways you can denote it, and it doesn't matter. There's no preferred way. You can do any of them. But let's not stop there, because let's think about negatives. What does a negative mean? We don't have any negatives here anywhere. Let's just look at a different vector. Okay, that's d. Let's just call this vector, which is also 6 miles long, but which is at 45 degrees. So I just put a second vector in there. Just say I'm going to call it s. S, it's another displacement vector. It's 6 miles, but it's 45 degrees from the plus x-axis, right? So s is 6 miles, 45 degrees from the plus x-axis, clockwise from the plus x-axis, counterclockwise from the plus x-axis. Okay, but notice that what is minus s? Minus s. Minus s equals minus 6 miles, 45 degrees counterclockwise from the plus x axis, minus s is equal to, we can pull that minus sign out and say it's 45 degrees counterclockwise from the minus x-axis, right? So minus s is actually d. Huh. So d is minus s. So that's another way to designate the d vector, right? So therefore, if minus s is minus 6 miles, 45 degrees counterclockwise from plus x, then d is minus 6 miles, 45 degrees counterclockwise from plus x. Okay, so what is the negative of a vector? So we're talking about how to denote vector directions. You can denote them by writing down the angle that you are from a axis that you have defined, but you can also use minus signs to your convenience, right? Understanding what a minus of a vector is. Minus of a vector is the same vector pointing in the opposite direction, right? So I don't know if you can see what I'm doing here. Whoops, I don't think I can do what I was going to do. I wanted to, whoa, it's not working. Okay, I took that minus s vector. It doesn't look quite, it was meant to be the same length as d. Anyway, I took that vector and just moved it parallel. Okay, that wasn't working out so well for me, so I just drew a new vector. I took d and I just put the arrow on the other end. And so if you take the same vector, but you change the arrow to the other end, you're just taking the negative of the vector. So where I have the vector d pointing 45 degrees in that third quadrant, I now have minus d, which points in the opposite direction. So it points 45 degrees in the first quadrant. Okay, so that's how we denote vector directions and the negative of a vector.